A vacuum leak happens when unwanted air enters your engine's intake system after the mass airflow sensor or throttle body. This messes up the air-fuel mixture, causing your engine to run lean with too much air. This can lead to incomplete combustion and other problems. Ignoring leaks can lead to serious engine damage like warped valves. One of the first signs of a vacuum leak is a high idle. Normally, your engine idles around 600 to 800 RPM. With a vacuum leak, it might jump to 1000 to 1500 RPM. This occurs because the engine control module tries to compensate for the extra air by adding more fuel to keep things balanced, but it can't fully correct the problem. Rough running is another common symptom of a vacuum leak. You might notice vibrations, misfires, or hesitation when accelerating. This happens due to erratic ignition timing and imbalances between cylinders because the air-fuel mixture is off. The engine isn't operating smoothly. A vacuum leak often triggers the check engine light. The onboard diagnostics, or OBD2 system, detects the lean condition or misfires and sets diagnostic trouble codes, also known as DTCs. Common codes include P0171 for System 2 lean, P0300 for random misfires, and P442 for evap system leak. A scan tool can read these codes to help diagnose the issue. Per NHTSA 2025 data, vacuum leaks account for 5 to 7% of all check engine light triggers in internal combustion engine vehicles. Vacuum leaks often occur in hoses, gaskets, and components connected to the engine's vacuum system. Common culprits include deteriorated rubber hoses, loose clamps, cracked intake manifolds, or faulty PCV valves. Salt-induced corrosion is a factor for urban drivers. These components are part of the engine's vacuum system. Diagnosing vacuum leaks can involve using tools like vacuum gauges or smoke machines. A vacuum gauge measures the vacuum pressure in the intake manifold. A drop below 18 to 20 inches of mercury at idle often indicates a leak. Smoke machines pump smoke into the intake system to visualize where air is escaping. Modern vehicles use AI-enhanced OBD2 systems to predict leaks. DIY diagnostics via apps are also on the rise. Repairing a vacuum leak typically involves identifying and replacing the faulty component. Common issues include cracked hoses, loose clamps, or damaged intake manifold gaskets. Repair costs vary based on the severity of the leak and the parts required. Simple hose replacements may cost around $50, while more extensive repairs involving gaskets can reach $500. To prevent vacuum leaks, mechanics recommend annual inspections of hoses and components, particularly in high-mileage vehicles over 100,000 miles. With the rise of electric vehicles, vacuum leaks are expected to become less common as EVs eliminate the need for traditional vacuum systems. For existing internal combustion engine vehicles, regular maintenance and prompt repairs are essential to prevent vacuum leaks. Predictive maintenance, using telematics, helps detect potential leaks before they cause problems. Using recycled materials for hoses is an emerging trend to create more durable and eco-friendly components. Ignoring vacuum leaks can lead to escalated problems and serious engine damage.